The origin of optics from ancient philosophy to modern science. What is light? Is it made of tiny particles, waves, or something else entirely? This mystery has fascinated humans for over 2 millennia, and the search for an answer takes us through an extraordinary journey beginning in ancient India, continuing through Greek geometry, reaching new heights in the Islamic Golden Age, and finally transforming into modern optics in Europe. By the end of this video, you will understand not just the science, but also the cultural exchanges and debates that shaped optics. Our first step is India, around 1500 BCE. The Rig Veda, the oldest of the Vedas, 1500 to 1200 BC, contains some of the earliest references to light in Indian thought. Light is seen as the medium through which you humans perceive reality and connect the outer world to human consciousness. This idea laid the conceptual foundation of later Indian philosophical school, Nyaya, Vaisesika, and Vedanta, that debated whether light is made of particles, rays, or pulses or waves. Centuries before Greek and European optics, the ancient Sankhya philosophy, 1000 BCE, treated light as a form of energy, Shakti, rather than substance. This is closer to a field-like concept, but not developed into a wave theory. Philosophers of the Vaisesika school, founded by Kaṇāda in 600 BC, proposed that light consists of tiny particles, tejas or nu, traveling in straight line with infinite speed. This is an important geometric idea. The rectilinear propagation of light. That's remarkable because later European corpuscular theories, including Newton. The Nyaya school in 200 BC also studied vision and perceptions, debating whether light originates in the eye or the object. It discussed perception, reflection in mirrors, and the role of straight line rays, which is called Rasmi. These explanations resembles an early version of ray optics. Now, Buddhist Abhidharma, a 3rd century BC to 5th century BC, sometimes describe light as a series of momentary pulses, Khanika. This is conceptually interesting, but not a wave model in the physical sense. Now, astronomical texts like the Surya Siddhanta, around 4th to 5th century CE, treated light geometrically. Rays explain shadows, eclipse, and the size of celestial bodies. Aryabhatta, 476 CE, described how moon shines by reflecting sunlight and why eclipses occur when the rays are blocked. Later, Bhaskara too, in 12th century, refined this idea in the Siddhanta Shiromani, his book, analyzing planetary visibility through straight line rays. Now, the wave-like ideas, Sanskrit texts such as Yoga Vasishta and Vaisesika discuss light as traveling in rays or pulses. But these descriptions were more philosophical than quantitative wave theory. Finally, Christian Huygens in 1678 is credited with systematically formulating the wave theory of light, explaining diffraction. Ancient India inspired ideas through light propagation, but it didn't formalize the mathematical wave theory as of we don't know. So, in India, optics was closely tied to astronomy and philosophy, with light seen as a physical entity moving in straight line. Around 300 BC, Euclid wrote his Optics. Unlike Indian philosopher, he imagined vision as rays emitted from the eye. Using the geometry, he explained perspective, apparent size, and the laws of reflection. Later, Hero of Alexandria, the 1st century, proposed that light follows the shortest path when reflecting. Historians debate whether this was truly the principle of least time, but it was an early geometric insight how light behaves. By the 2nd century CE, Ptolemy combined geometry with experiment. He measured angle of incidence and refraction using water and glass. Though he didn't discover the exact law, the great contribution was to mathematize optics, turning it into a discipline of lines, angles, and the geometry of vision. Centuries later, during the Islamic Golden Age, optics took a new form. The greatest figure was Ibn al-Haytham, 965 to 1040 C approximately, or Alhazen. His kitab al-Manazir, Book of Optics, is often called the Book of Modern Optics. Challenged the old Greek eye emission theory. Through experiments like the famous pinhole camera obscura, he proved that light enters the eye from external objects. Alhazen also analyzed reflection and refraction with a blend of geometry and experiment, describing how light bends when passing through different media. His systematic methods influenced later science enormously. Other Islamic scholars like al-Kindi and Avicenna also debated light, vision, and color. But it was Ibn al-Haytham who emphasized experimentation, making optics a true empirical science. It's tempting to imagine a straight line of transmission: India, Greece, Islamic, Europe. But the truth is more complex. Greek and Indian optics often develop independently. Later, many Greek texts, Euclid, Ptolemy, Galen, were translated into Arabic. Some Indian astronomical works also circulated in the Islamic world, influencing astronomical tables, etc. From Arabic, these works reached medieval Europe through translations in Spain and Sicily. But the Renaissance, Europe had access to both Greek geometry and Arabic experimental science. So the story is less about one-way flow and more about a cross-cultural relay race, each civilization adding its own piece to puzzle. In Europe, optics were reborn. Roger Bacon in 13th century studied Alhazen's work and promoted experimentation. Kepler in 17th century explained how the eyes form images on the retina, breakthrough in physiological optics. Descartes in 1637 described refraction and explained rainbow using geometry. Newton finally in 1670s used prism to show that white light is a mixture of colors, supporting his corpuscular theory of light. But not everyone agreed. Huygens proposed the wave theory. Thomas Young in 1801 demonstrated interference, and Fresnel developed wave optics further. Finally, in the 19th century, James Clerk Maxwell united optics with electromagnetism, showing that light is an electromagnetic wave. So where did optics come from? India gave us the particle theory and ray geometry. Greece gave us mathematical optics. The Islamic Golden Age gave us experiments and scientific method. Europe combined all this into modern science. The story of optics is proof that science is not the gift of a single culture. It's a global collaboration across centuries. So, next time you see a rainbow or sunlight through glasses, remember you are seeing the result of 2000 years of human curiosity, stretching from Kaṇāda, the atomic theory, to Maxwell. If you enjoyed this journey through science and history, don't forget to like, share, and subscribe, because you have got many more stories like this waiting for you. Thank you.